Alright, so example of how we're going to use Planck's equation in order to figure out how much energy is contained in some of these photons in your spectral signatures. And we're going to use hydrogen because Bohr used hydrogen. And hydrogen was simple because we only have a few distinct lines. So for the colors found in the hydrogen atom, find the amount of energy contained in the photons of visible light in the emission spectrum. So here's a copy of the emission spectrum of hydrogen. And I thought I would review also how to get the frequency from the wavelength. So I'm going to do this for purple. And I'm going to call the wavelength of the purple or violet emission 400 nanometers. And if you remember, we moved the decimal place 9 times to the left. 9 times to the left in order to get 4.00 times 10 to the negative 7 meters. Always transfer nanometers to meters. So then, to get the frequency, I remember C is wavelength times frequency. I can isolate frequency by dividing by the wavelength. And now I'm ready to fill in my numbers. Speed of light, 3.0 times 10 to the 8 meters per second, divided by the wavelength, 4.00 times 10 to the negative 7. And when I do this, we should get 7.5 times 10 to the 14th. And the units for frequency, once again, as you can see down below, meters cancel out. I have units of 1/seconds. So I've got the frequency. So my next task here is to get the energy of that violet photon. So here comes Planck's equation. Energy is Planck's constant times the frequency. And I know Planck's constant is going to be 6.626 times 10 to the negative 34th, and the units are joules seconds. It is a proportionality constant that relates frequency to energy. And I'm going to multiply that by the 7.5 times 10 to the 14th, 1/seconds. You'll notice here that the seconds cancels out, leaving us with joules, which is the units for energy. So, finding a calculator, which I should have had on hand earlier. Now I have a calculator. I do parentheses 6.626 times 10 to the negative 34th. And then I multiply that by 7.5 times 10 to the 14th. And I get a value of 4.97 times 10 to the negative 19th joules. That's how much energy is contained in that one little violet photon. Pretty soon we're going to relate that also to joules per mole. So there is how to find the energy contained in a photon of purple visible light, which can correlate to any color that you saw on your emission spectrum. There you go.